So today we're going to talk about graphing inequalities. This isn't a lesson by itself in the book, but it does apply to things that we're about to learn. So I thought it was important enough, and there's enough little tiny details that it was worth its own day. You might have seen it in sixth grade. You might remember some of this, but regardless, I wanted to give you the information before we dove into the heavy duty stuff of the chapter. So let's talk about what an inequality is. If you're good with your ELA prefixes, in means not. So the word literally means not equal, right? Because equality would be equal. So these are things that are not equal. Equations have equal signs. X equals 8. That means that the value of x is 8. But these are things like greater than, less than. So they're not equal to. We use the number as a reference point, but they're not actually equal to it. So you know these two symbols. You've studied them since very early on in school. Most students know where to put the numbers. They know that the pointy part means the small number and the open part means the big number. Where they get tripped up is how to read it. Well, think about how we read a book. In English, we read from left to right. So when you see one of these signs, you also read it from left to right. The first thing you say is the name that you give it. So I see here the pointy part comes first. This one's called less than. I see here the open part comes first. This one's called greater than. Now, there are two new signs or two related signs that we're going to introduce that have these lines underneath them. So this is less than or equal to, and this is greater than or equal to. A real life example so that you can kind of see when you would use these and what the difference is. Let's think about a theme park or roller coaster, something like that. For this one, for example, you might say that you must be under 6 feet tall to ride the coaster. If you're 6'1", you're going to bash your head on something. So they want to make sure that you're safe. You must be under 6 feet in order to ride a particular ride. The opposite of that, they want to make sure that you're tall enough and you're not going to go flying out of the seat. So you must be over 48 inches to ride another coaster. If you're exactly 48, they're not letting you on. Like, oh, I just made it to the line on the measuring stick. You have to be above that line. You must be over 48 inches. Okay, let's do it with the equal sign. Free admission for kids 13 and under. If you're 13 today and tomorrow you'll turn 14, today you get in free because you're 13, but tomorrow you'll have to pay. If you bring a little brother or sister and that little brother or sister is 6, they get in free because they're under 13. The reverse of that is that you must be a certain age in order to enter. Maybe it's a nightclub or a bar or a casino, and they've set limits. You must be 21 years old to enter. If today you are 20 and tomorrow is your birthday, you can't go in today, but at midnight, when you turn 21 officially, then you can walk in the door. Okay, so 21 allowed in, under 21 not. These two actually add one additional value over these two. Now, we're going to graph these. The whole point of this is to create a picture of all the possibilities. All right, if I say anyone over 21 can enter, let's make a list of all the ages. 21, 22, 23, 24, 25, until your grandma gets to come with you. You're going to be here a long time if you have to make that whole list. So by graphing it, you can very quickly and very easily show all the possibilities. Okay, the type of graph, and I'm just going to put these and then I'll show you the examples in a minute. Both of these will be open dots, and I'll show you what I mean by that in a minute. The two with the equal to will be solid or filled in or colored dots, depends how you say it. The way that I've always remembered it, extra line means extra coloring. No line, no coloring. You could also think of it as when I make a dot, remember how we graph, like when we give you the graph paper and say, here, make a dot, make a picture? You're making dots. You're putting it on that number. Well, this can't actually be on that number. That'll make more sense to you in a minute. Okay, so here are some steps to actually graph these inequalities. First, you'll make a number line, and I'll show you some shortcuts for that so you're not here all day labeling. Make the dot, draw the arrow. It's that simple. Okay, let's go to my first example. Your inequality is x is less than 3. That point came first, so I said less than. Okay, number 1, make a number line. You don't have to label every single number. You need to have at least 2. I usually say 0 and the number that's listed. If you want to put more in, go right ahead. But if it takes you 10 minutes to do a problem, I'm not going to feel sympathy for you. 0 and the number in the problem will be just fine for us. Okay, we're going to mark a dot at that number, right? 3 is in the problem. This does not have an equal sign with it. It's just the less than. So I'm going to put an open dot. Now, I made that dot ridiculous. Sometimes I'll raise it above and do it above the number line, which will drive your next year's teacher nuts. So I'm trying to break that habit. But sometimes it's too much on the line. So by putting the graph above it, it's always been easier for me to see. But my colleagues get upset with me. So I'm trying to make them happy too. Now, give me some examples of numbers that are less than 3. I could ask a young student that. Tell me some numbers that are smaller than 3. What would they say? 2, 1, 0. You know about the negatives. So where are those numbers on the number line? They're right here, right? So I'm going to draw my arrow that way. You've now graphed that inequality. You can get as close as you ever could possibly imagine, 2.999999999999999 without ever actually getting to 3. You're going to get so close. That's what that open circle means. You can't ever actually get 3, but you can get as close as you could ever possibly imagine. And then all the stuff below it. Would negative 100 be an answer for this? Sure. Would 3/4 be an answer to this? Sure. Would 3.2 be an answer to this? No. 3.2 is over here. Okay, let's do our next one. M is greater than or equal to 4. Step 1, make my number line. Let's go for 0 and 4. You cannot just put the number in the problem. You have to have some other reference. 0 seems to be the most obvious. Now, this one is allowed to be 4. It has that extra line. So we're going to use a solid dot. It can actually be there. I can stand on 4. 4 is an acceptable answer. And then I want all the numbers bigger than 4. So let's talk to our young student again. Tell me some numbers bigger than 4. And they'll answer me in their cute little voice. 5, 6, 7, 900 million, 427, 3. No, 3 is not an answer, sorry. Okay, so where are all those numbers? Bigger than 4. Sometimes I'll color it in here to make it obvious that that's the one I want. You've just graphed m is greater than or equal to 4. It can be 4, it can be 4.1, it cannot be 3.9. 3.9 is down here too low. Why is it a solid circle? Because it can equal it. You're actually allowed to stand there. Why was this an open circle? It's not allowed to equal it. You can't stand on 3. You can get really close, but you can't actually stand on 3. All right, 2 more examples. P is greater than negative 8. Yes, this even works for negatives. Draw our number line. Look at that. I'm not even putting arrows on the end anymore. Move this so I can actually write. There we go. All right. What kind of dot? Open. Good. That'll go at negative 8. And I want all the numbers bigger than negative 8. I know all the positives are bigger, right? If I'm talking about temperature, all the warm temperatures are over here. So let's go that way. There. I've graphed all the options greater than negative 8. Make sure that your dot and your arrow connect too. Last example. J is less than or equal to 0. Draw my number line. I got to get 2 numbers on here, don't I? All right. I'll be crazy and put 3 numbers. You cannot have just a single number. All right. I want things that are less than or equal to 0. Extra line, extra coloring, at the number in the problem. And then I want all the things smaller than 0. Okay, kindergartner, what are things smaller than 0? -1, -2, -3. Well, they're all down here. So there we go. That's all there is to it. Every single one of these, make the number line, decide on your dot, decide on your arrow. Tomorrow, we will roll this in and combine it with solving inequalities.